Hello, my name is Daniel, and today we will be going through the AMC 12 from the year 2000. So let's get started. First problem, in the year 2001, the US will host the IMO. Let I, M, and O be distinct positive integers such that the product I times M times O equals 2001. What is the largest possible value of the sum I plus M plus O? Okay, so since we have to get the largest value of their sum, and they multiply to get 2001, that means we want one number to be the largest it can be. So if we didn't have that distinct clause, then we would just have gone for 2001, right? But then since they can't be the same, then one has to be 1, and then one has to be the next lowest power. Next lowest factor, which is 3, because this is not an even number, but it's divisible by 3. And if we divide 2001 by 3, that will just be 667, right? So if you add these up, this gives us 671. This is E. Number 2, 2000 times 2000 to the 2000 power is just 2000 to the first plus 2000's power. So this is just 2000 to the 2000 first power. The answer is A. Number 3, each day Jenny ate 20% of the jelly beans that were in her jar at the beginning of that day. At the end of the second day, 32 remained. How many jelly beans were in the jar originally? Okay, so since Jenny ate 20% each day, that means 80% was left each day, right? So if we say that X jelly beans were in the jar originally, that means X times 4 over 5, this is for 1 day, and this is for one more day, right? Because this is the second day. This equals 32, because 32 remained. So X equals 32 times 25 over 16 equals 50, right? So the answer is B. Number 4, the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, and so on, starts with 2 ones, and each term afterwards is the sum of its 2 predecessors. Which one of the 10 digits is the last to appear in the units position of a number in the Fibonacci sequence? Okay, we just want the units digit of the number in the Fibonacci sequence, and so let's just write it all down. And see which one comes out last, right? So we have, let's just start from 13 and 21, because none of these numbers are in the answer choices. So let's just start from 3 and 1. So that would give us 4 and 5, 9, 4, and then 3, and then 7, and then 0, and then 7, right? Do we have what we need? Yeah, we have 4, and then 9, and then 7, and then 0, right? So we have 4, 9, 7, 0, so the last is 6. The answer is C. Number 5 is if the absolute value of x minus 2 equals p, where x is less than 2, then x minus p equals. Okay, so since this is the absolute value, but then x is less than 2, that means just x minus 2 itself is a negative value. And so if we take the absolute value, the sign would be reversed. So it's 2 minus x equals p, right? And that just gives us that x minus 2 equals negative p, right? And then we want x minus p, so we can just plus 2 minus p on both sides, right? And so this gives us x minus p, and this gives us 2 minus 2p. So the answer is C. Number 6, 2 different prime numbers between 4 and 18 are chosen. When their sum is subtracted from their product, which of the following numbers could be obtained? 2260, 119, 194, or 231? Okay, so we want their sum. So let's say the prime numbers are a and b, and we want the sum subtracted from their product. So it's ab minus a minus b. This is a plus 1, and this is a minus 1 times b minus 1 minus 1, right? These values, there are these values, right? And so if we add 1 to each of them, then what we get is this value. And so if we add 1, we get 23, 61, and 120, and 195, and 232, right? And so these values, they have to kind of split into two numbers like these that are prime minus 1s. So prime minus 1 times prime minus 1, right? Okay, so 23, this is prime, so this is out. 61, this is prime, so that's also out. And 120, let's see about that. If we have 12 here and we have 10 here, then we will get a equals 13 and b equals 11, and that does match this condition, so that is the answer. It's C. Number 7, how many positive integers b have the property that log b to 729 is a positive integer? Okay, so log b 729. Right, this is 729. This is 81 times 9, which is 3 to the 6th power, right? And so b can be 3 to the first power, or 3 to the second power, 3 to the third power, or 3 to the 6th power. So this is 4. So the answer is E. Number 8, figures 0, 1, 2, and 3 consist of 1, 5, 13, and 25 non-overlapping unit squares respectively. If the pattern were continued, how many non-overlapping unit squares would there be in figure 100? Okay, so let's look at the pattern. Figure 0, we have just 1 square. Figure 1, we have 1 square plus 4 more. Figure 2, we have 1 square plus we have 12 more. And figure 3, we have 1 square plus 6 times 4, so we have 24 more, right? And so now we can kind of divide these into 4 different sections, like these. And so what we can see is that these different sections, they all increase by the same pattern, right? And so each of these blue regions, they are 1, and then 1 plus 2, and then 1 plus 3, 1 plus 2 plus 3, and then so on, right? And then we have 4 of these, right? So we have 4 of these blue, and so it asks how many non-overlapping unit squares would there be in figure 100. And figure 1 had 1, figure 2 had 1 plus 2, figure 3 had 1 plus 2 plus 3, right? And so figure 100 would have 1 plus 2 plus 3 all the way to 100, right? Plus 100. So this is 100 times 101 over 2, right? But then we have 4 of these, so we just have to multiply by 4. And so this is 2 times 100 times 101. So this is this is 20200, right? And then we just have to add this 1 in the center. So plus 1. So this equals 20201. The answer is C. Number 9. Mrs. Walter gave an exam in a math class of 5 students. She entered the scores in random order into a spreadsheet, which recalculated the class average after each score was entered. Mrs. Walter noticed that after each score was entered, the average was always an integer. The scores were 71, 76, 80, 82, and 91. What was the last score Mrs. Walters entered? Okay, so since this is just taking the average of the scores, then we can just subtract the same number from all the scores, and the pattern of the average would be the same, right? So if we take out 70 from all of these scores, we have 1, 6, 10, 12, and 21, right? And we want the last score Mrs. Walters entered, and so we have 5 scores in their order, and the first 2 have to be a multiple of 2, and the sum of the first 3 have to be a multiple of 3, and the sum of the first 4 have to be a multiple of 4, like that, right? And so so for the first 2 numbers to be an even number, then it has to be either 1 and 21, or two of those 3, right? But then since the third one also has to be a power of 3, then what if it's like 6 and 12, right? Then the only way for this to be a multiple of 3, that would be making 21s in here. And now we can see that the sum of these numbers, they are 39, right? And so to make the sum of these 4 numbers a multiple of 4, then that means that we need 1 here, right? And so this will give us 40, and if we put 10 here in the last place, then these whole sum will be 50, and so that is like so that is a multiple of 5. And so it asks what was the last score Mrs. Walters entered, so that's the value that corresponds to 10, and 10 corresponds to 80 because we subtracted 70 from every value, so the answer is 80. It's C. Number 10, the point P equals 1, 2, or 3 is reflecting the xy plane, then its image Q is rotated 180 degrees about the x-axis to produce R, and finally R is translated 5 units in the positive y direction to produce S. What are the coordinates of S? Okay, so let's draw this out. We have the x, y, and z coordinates, and we have 1, 2, 3, so we will have 1, 2, 3, and that will be something like this, right? And so if we draw this cube, then our point will be right here. And then if it's reflected in the xy plane, then that just means this sinks down to the bottom, right? And so this will go something like this, like 1, 2, 3, and then this will be the same, like that, right? Like that, and then our point will go here, right? This line should be on top of that, right? So like that, and then R has to be translated, it has to be rotated 180 degrees about the x-axis. Okay, so if that were to happen, then we would have something like this. So we would have -2 here, and then we would have it, yeah, so we would have it right over here, like that. And so this would be our third point, right? Because this one is that's flipped 180 degrees. And then it's translated 5 units in the positive y direction. Okay, so if you see this is 1 unit, 2 unit, 3 unit, 4 units, so we need 1 more unit to go. So we are in this point, and then and the height and the other stuff, height and the other things will be the same. So this will be our last point, and these coordinates, they are x is 1, so it's 1 comma 1 comma 3 comma this is 3, so we have 1 comma 3 comma 3. The answer is E. Number 11, two non-zero real numbers a and b satisfy a b equals a minus b. Which of the following is a possible value of a over b plus b over a minus ab? Okay, so if we combine these, then a squared plus b squared over ab minus ab, this has to be it, right? So it's so it's all over ab, and a minus b squared plus 2ab and then minus ab, right? And so this equals ab equals a minus b, right? So this is ab squared plus 2ab all over ab, and then we have to do minus ab. So this is, if we cancel, ab plus 2 minus ab, so the answer is 2. It's E. Number 12, let let a, m, and c be non-negative integers such that a plus m plus c equals 12. Where's the maximum value of a times m times c plus a times m plus m times c plus a times c? Okay, so since the sum is constant and we want the maximum value of these, then for us to get the maximum value, then a, m, and c would have to be the same, have to be equal, right? So they would be equal to 4, because 4 plus 4 plus 4 equals 12. And so if we just put in 4 and 4 and 4 here, this will give us 4 cubed, so 64, no, sorry, so 64 plus 16 plus 16 plus 16, this equals 16 times 7, and so this equals 42 plus 7, so this is 112, so the answer is E. Number 13. One morning, each member of Angela's family drank an 8-ounce mixture of coffee with milk. The amounts of coffee and milk varied from cup to cup, but they were never zero. Angela drank a quarter of the total amount of milk and a sixth of the total amount of coffee. How many people are in the family? Okay, so let's say that there are X people in Angela's family. So there are X people, right? So they drank a total of 8x ounces, so 8x equals the total amount of milk, let's say it's M, plus the total amount of coffee, let's say that's C, right? And then Angela, so she drank 8 ounces, 8 equals a quarter of the total amount of milk, so 1/4 of M, plus a sixth of the total amount of coffee, plus 1/6C. Okay, so if we cross multiply, we get 12 times 8 equals 3M plus 2C, right? But then since M plus C equals 8x, then that means this equals M plus 8 times 2C, so M plus 8 times 2C, no, 8 times 2x, right? And so we get that M, so we get that 12 times 8 equals M plus 8 times 2x, so M is a multiple of 8. And so let's say this is 8k, right? So 12 equals k plus 2x, right? So here x has to be less than, no, sorry, k has to be less than x, right? So the way that this is possible is if k equals 2 and x equals 5, right? Then it will be okay, right? And so if we put k into here, then that means m equals 16, right? And then x equals 5, so there are 5 people in the family. It's C. Number 14, what is the mean, median, and mode of this list? If they are arranged in increasing order, they form a non-constant arithmetic progression. What is the sum of all possible real values of x? Okay, so we need the x values, right? And so first of all, the mode. The mode, this just equals 2, right? Because there are 3 2's. and we want the mean and the median, right? And the median, if we arrange the numbers in order, we have 2, 2, 2, 4, 5, and 10, and we don't know where x can be, right? And so the median can be x when it is 3. Yeah, so when it is 3, or it can be 2 if x is less than 2, or it can be 4, right? 4 if x is greater than 4, right? And so the mode is 2, and the median is that, and the mean, this is, if we add all these together, then what do we get? We get 25 plus x, so 25 plus x over 7, right? And so if they are arranged in increasing order, they form a non-constant arithmetic progression. And so if we have 2 and then the median and then the mean, 25 plus x over 7, they will form will form an arithmetic progression, right? But then they are non-constant, so these just can't be like increasing by 0, right? So this cannot be 2, and so the median cannot be 2. So we can take this away, and so the median is either x in the middle, which is 3, or it's 4 when x is greater than 4, right? And so now let's divide it into 2 of those categories. So if median is 3, so if median is x, then x equals 3, right? And so we will have to be 2 and then 3, which is x, and then it will have to be 25 plus 3 over 7. This is 28 over 7, which is 4. So that would be 2, 3, and 4. That is indeed a non-constant arithmetic progression. So this is one of the answers. So x can be 3. Okay. And then if the median is 4, right? Then x has to be greater than 4. X has to be greater than 4. And so that would be 2, 4, and 25 plus x over 7, right? And so for this to be so for that to be a non-constant arithmetic progression, then this value has to be 6, right? So 25 plus x over 7 equals 6. So x equals 42 minus 25, and this is going to be equal to 17, right? And so since this value of 17 is greater than the value of 4, x equals 17. X equals 17, this is also okay. So we have values of 3 and 17, so they equal 20, so the answer is E. Number 15, let f be a function for which f x over 3 equal this thing. Find the sum of all values of z for which f of 3z equals 7. Right, okay, so since if f of x over 3 equals x squared plus x plus 1, then what we want to do is we want to substitute 3z into x over 3, right? So if x over 3 equals 3z, then that means x equals 9z, right? So if we substitute x equals 9z into there, then what we will get is 9z squared plus 9z plus 1. So this is 81z squared plus 9z plus 1, right? And so the sum of all values, so the sum of its roots, this is negative 9 over 81, right? Because this is 9 and this is 81. And so this is negative 1 over 9. So this is the answer. It's B. Number 16, a checkerboard of 13 rows and 13 columns. Yeah, so a checkerboard of 13 rows and 17 columns has a number written in each square beginning in the upper left corner, so that the first row is number 1, 2, all the way to 17, the second row 18, 19 to 34, and so on down the board. If the board is renumbered so that the left column top to bottom is 1, 2, up to 13, then the second column 14, 15, up to 26, and so on across the board. Some squares have the same numbers in both numbering systems. Find the sum of the numbers in these squares under either system. Right, okay, so we have a checkerboard of 13 rows and 17 columns, so it's going to be like this, and then goes and so on, and like this, right? Maybe a little bit more closer, like that, so on, right? And then let's say that if the square is this one, then let's say that this much amount is A, and the amount it went down, it's B, right? And so every kind of every square on the checkerboard would be a distinct value of a comma b, right? Yeah, so if we number it in the first way, then this would be how it's numbered. And so this would be numbered 17 times b minus 1. So 17 times b minus 1, and then we have a more, right? So plus a. And then this is equal to, if we number it in the second way, so the left column top to bottom is 1, 2 to 13, so this is going to be something like this, and then we are going to come this much more, right? And so that will be a minus 1, yeah, so that will be 13 times a minus 1, 13 times a minus 1, because this long is 13, and so we have a minus 1 of them, and we have additional b more, because this is b, so plus b, right? And so if we expand that, we have 17b minus 17 plus a equals 13a minus 13 plus b, right? And so we have that if b goes there, and if 17 goes there, if a goes there, then that will give us 16b. 16b equals 12a plus 4, right? So 4b equals 3a plus 1, and so and so this has to be met, that condition has to be met. So if we look at a and b, possible a and b values, if like this is 3a plus 1 and this is 4b, then they have to be the same, right? And then so we will have then 3 times a plus 1, no, 13 times a plus 1 minus, 13 times a minus 1 plus b, right? Because this is the value that we want. This is the number that was given, so that's this. And so if we do that, then first of all, we have a and b equals 1 and 1, and we can have a and b equal 5 and 4, or 9 and 7, or 13 and 10, or 17 and 13, right? And so for this one, that would just be the first number, which is 1, and then 5 and 4, that would be 13 times 4 plus 4, which is 14 times 4, which is 56, and then 9 and 7, that would be 13 times 8 plus 7, so that would be 111, and then 13 and 10, that would just be 13 times 12 plus 10, so that would be 156 plus 10, so that's 166, and 17 and 13, that would just be 17 times 13, so that would be 221. And so what we want to do is we want to add all these values together. And so if we add these numbers together, we are going to get 555, 555. So the answer is D. Number 17, a circle centered at O has radius 1 and contains the point A. The segment AB is tangent to the circle at A, and angle AOB equals theta. If the point C lies on OA and BC bisects ABO, then OC equals what? Yeah. Okay, so if we look at the answer choices, they are like all in terms of trig functions, right? And so first, what we want to do in this diagram is we want to make a line from C up, so that goes to 90 degrees against BO, like that, right? Because that way, this is also right triangle, and so this triangle and this triangle, they would be congruent, right? And so if we say that OC equals A, because that's what we want, then AC would be 1 minus A, right? If we say that OC equals A, then AC would be 1 minus A, and since this value and this value are equal, then this would also be 1 minus A, right? But then this is theta, right? And so that would mean that sine of theta, this will be this will be 1 minus A over A, right? So this will be 1 minus A over A, and so A sine theta, this will be 1 minus A, so A times 1 plus sine theta, this will be 1, right, because A is coming back there, and so A equals 1 over 1 plus sine theta, so we can find this value in D, so the answer is D. Problem number 18. In year n, the 300th day of the year is a Tuesday. In year n plus 1, the 200th day is also a Tuesday. On what day of the week did the 100th day of year n minus 1 occur? Okay, we first want to calculate the distance from the 300th day to the year to the 200th day of the next year, right? So the 300th day of year n to the 200th day of year n plus 1, right? This gives us 65 days plus 200 more days, right? But then this is assuming assuming that n is not a leap year, right? Because if n was a leap year, then this would be just 66, right? But then let's assume it's not a leap year, and let's say it's 65. So this is 265, which is, if we divide it into multiples of 7, this would be 210 plus we have 55 left, so 49 plus 6, right? Okay, so this is a multiple of 7 and this is a multiple of 7, but this is not a multiple of 7 and it has to be, right? And so what that means is that this should have been 7. And so that means that this should not have been 265, that should have been 266, right? And so that means there were actually 66 days left in the year n, right? So this means that n is a leap year. N is a leap year, and so that means that n minus 1 is not a leap year, right? So n minus 1, not a leap year, not a leap year, right? And so this means the 100th day of n minus 1 to the 300th day of n. So the distance, that would be just 100 to 300 in like a normal year, right? So the 100th of n minus 1 to the 300th day of n plus 1. This equals from 100th day of n minus 1 to the last day of n minus 1. That's 365 minus 100. That's 265, and then we have 300 more plus 300. This equals 565, right? So that was 565 days ago, right? So the 100th day of year n minus 1 occurred 565 days ago, and so 565 days ago. But then 560 is a multiple of 7, 7 times 80, right? And so that means that 560 days ago is equal to 5 days ago by like day of the week, right? So this is equal to 2 days later, 2 days later. And so since the right now is a Tuesday, that means 2 days later than Tuesday is Thursday. So the answer is Thursday, it's A. Number 19, in triangle ABC, AB equals 13, BC equals 14, AC equals 15. Let D denote the midpoint of BC, and let E denote the intersection of BC with the bisector of angle BAC. Which of the following is closest to the area of the triangle ADE? Okay, so first let's draw this triangle, like a diagram like this. So this will be our triangle. So first of all, D is the midpoint of BC. So this and this, they would have the same length. And we know that AB is 13, BC is 14, and AC is 15, right? So that means DC, this would be 7, right? And then E is the intersection of BC with the bisector of angle BAC. Okay, so this and this angles, they are the same, and we want the area of the triangle ADE. So all we want is the height, and so all we want is the height like this of the triangle and the base length, right? So first, let's get on finding the base length. So let's say that BE is A and ED is B. So A plus B plus 7 equals 14. That means A plus B. So that means A plus B is 7, right? That's our first condition. And our our next condition is that since these two angles are equal, that means the ratio of the length from AB to BE is equal to AC to CE, right? Is equal to AC to CE. And so what we now get is A over 13 is equal to B plus 7 over 15, right? So 15A equals 13B plus 13 times 7, which is 91, and A plus B equals 7, so we wanted to get B, right? So if we substitute A with 7 minus B, then we will get 15 times 7 minus B equals 13B plus 91. So this is 15 times 7, which is 105, minus 15B equals 13B plus 91, right? And so we will have 28B, this equaling 14, so B is equal to 1/2. So B is equal to 1/2, so we have the length of the base, and now we want the length of the height, right? And so we want this length, But then if you had noticed from the start, this whole thing is 14, and since this is 13 and there's a right triangle, so you should have kind of suspected that this was going to be very clean, right? And indeed it is, right? Because this is 5 and this is 12 and this is 9, right? Because then this would all work out perfectly, right? This is 5 plus 9 equals 14, and 12, 9, 15, that's a 3 to 4 to 5 triangle, even though like it doesn't kind of look like it. And 12 to 5 to 13, that is a well-known Pythagorean triple, right? And so that just gives us the length of this, which is 12. And so our area of the triangle is 12 times 1/2 times 1/2. So this is 3, so the answer is C. Number 20, if x, y, and z are positive numbers satisfying these three things, then what is the value of x, y, z? Right, okay, so first of all, let's try to add these up together. Then x plus y plus z plus 1 over x plus 1 over y plus 1 over z. This would equal 4 plus 1 plus 7 over 3, and that would be 22 over 3, right? And then if we multiply all these values, then that would just be x plus 1 over y, y plus 1 over z, and z plus 1 over x, right? And so these would, and so we would get x, y, z from the first ones, and plus x plus y plus z plus 1 over x plus 1 over y plus 1 over z plus 1 over x, y, z, right? So this would equal 4 times 1 times 7 over 3, which is 28 over 3, right? 28 over 3. But then we saw this middle part here, right here, right? And so we can substitute 22 over 3 into here. And so if we do that, then this will equal x, y, z plus 22 over 3 plus 1 over x, y, z equals 28 over 3. And so x, y, z, so if we move this, then we will get that x, y, z equals 1 over x, y, z, 1 over xyz equals 28 over 3 minus 26 over minus 22 over 3, and this is 2, right? And so since xyz plus 1 over xyz equals 2, then that just gives us the value of xyz. xyz must be equal to 1, right? And so xyz is 1. The answer is B. Number 21. 3 points on the hypotenuse of a right triangle. Lines are drawn parallel to the lines of the triangle so that the triangle is divided into a square and two smaller right triangles. The area of one of the two small right triangles is m times the area of the square. The ratio of the area of the other small right triangle to the area of the square is, and that's what we want, right? So let's first draw a diagram of this, and that would be something like that, right? And so this would be the point on the hypotenuse of the right triangle, and so this would be the square, and these would be the two right triangles that the problem is talking of. And since the area of one of the two small right triangles is m times the area of the square, and so we can just say that the area of the square is 1 and the area of this is m, right? So to do that, we need that this is 1, so the side lengths are 1, 1, right? So this would also be 1 and this would also be 1, and the area is 1 to m, right? So this area is 2m, right? So the area is m, so this length, that will be 2m, so this is 2m, and since this to this ratio is same as this to this ratio, right? Then it will be 1 over 2m, right? And so the ratio of the area of the other small right triangle to the area of the square, it's this is 1, and we want the area of this, right? So the area of this would be our answer, since just the area of the square is just 1. So this is 1 over 2m times 1 times 1 over 2. So this is 1 over 4m, right? So the answer is, it's this, so it's D. Number 22. The graph below shows a portion of the curve defined by the quartic polynomial px equals x to the 4th power plus ax cubed plus bx squared plus cx plus d. Which of the following is the smallest? So we have all these different things, and let's just use this graph to find them out, right? So p of minus 1, that would be just p when it's minus 1, so that would be this value. This is like 4.4, 4.2, 4.3. And the product of the zeros of p. So so the product of the zeros, this is actually d, right? And then d gets and we can get d when it's p0, right? P0, and p0, it's like this. It will be about 5.1. It will be about 5.1. And then the product of the non-real zeros of p, this is let's do it in a different color. This is non-real zeros, so it's the product of all the zeros, so it's like 5.1 over the product of the real zeros, right? So yeah, so it's 5.1 divided by the product of the real zeros, so those are these two values, and this would be like 1.7 and 2.3, right? So this is 5.1 over 1.7 and times 2.3. And so this equals 5.1, 1 over 39.1, right? Sorry, this equals 5.1 over 3.91. So this is going to be less than 2, right? So this is obviously going to be less than 2. And for the sum of the coefficients of p, this is just 1 plus a plus b plus c plus d. This is p1, right? So that's p1, and we get a value of 3 point something, right? So this is 3 point something. So we don't need the actual value. And the sum of the real zeros of p, that's just this plus this. 1.7 plus 2 plus 3, this gives us 4, right? And so which of the following is the smallest? We have 4.3, 5.1, some value less than 2, 3 point something, and 4. So our smallest value is this one, so the answer is C. Number 23, Professor Gamble buys a lottery ticket which requires that he pick 6 different integers from 1 through 46 inclusive. He chooses his numbers so that the sum of the base and logarithms of his 6 numbers is an integer. It so happens that the integers on the winning ticket have the same property. The sum of the base and logarithms is an integer. What is the probability that Professor Gamble holds the winning ticket? Okay, so it said that the sum of the base 10 logs is an integer, but then that means that just log of a plus log of b plus all the way to log of something. This is going to be, it's 6 numbers, so log of f. This is going to be integer, but then this is just equal to log of a, b, c, d, e, f, right? So this is an integer, so that means a, b, c, d, e, f, right? So the product of the 6 numbers, this is going to be 10 to something power, right? So let's say it's 10 to the x power, right? And 10 to the x power, this is 2 to the x power times 5 to the x power, and so the individual numbers, they can be, so they can only have prime factors 2 and 5, right? So the numbers from 1 to 46 with prime factors only 2 and 5, they can be 1. So yeah, let's write this in different color. They can be 1, 2, 4, 1, 2, 4, 8, 16, 32, or if we have 5 in them, they can be 5, 10, 20, 25, and 40, and that's it, right? And so if we prime factorize these things, let's divide it by the factor of a. So if it's 2 to the 8th power and 5 to the bth power, let's write the values of a here and write the values of b there. And so one it will be 0, 1, 2, 3, 4, 5, and then these would just all be 0, right? So it's all 0. And from 5 to 40, 5 has 2 to the 0th power, and then it's 1, 2, 0, and then this is 5 times 8, so this is 3. And then the next ones we have 1, 1, 1, 2, and 1, right? And so now what we want to do is do a minus b, right? So a minus b, subtract a minus b, right? Because the 6 numbers a minus b sum has to be 0, right? 0 for 2 power, so for the power of 2 and the power of 5 to be equal, right? So that's why we are checking a minus b, and we want the sum of them to be the same, right? And we want the sum of them to be 0. And so if we do that, we have 0, 1, 2, 3, 4, and then 5, negative 1, 0, 1, negative 2, and 2, right? And so we need 6 distinct values of these that will make the sum 0. And to do that, we can have sums that, we can have a minus b's that are 0, 0, 1, 2, -1, and -2, right? And for values of 0, 0, -1, and -2, there's only one of each, and so we have no choice about which numbers to pick there. But then for these two numbers, 1 and 2, we have two choices for 1 and two choices for 2, right? So this is two choices for 1 and two choices for 2. So if we multiply them, we have four choices. So that means we have 4 sets of numbers in total. That satisfy satisfy the given condition that the sum of the base 10 logarithms is an integer, right? The condition, right? So yeah, so one of these 4 is a winning ticket, and Professor Gambles holds one of these, so his probability is 1/4. So the answer is B. Number 24, if circular arcs AC and BC have centers at B and A respectively, then there exists a circle tangent to both AC and BC and to AB. If the length of BC is 12, then the circumference of the circle is, right? Okay, so first of all, we have to draw a line from A to BC and to this tangent point, right? And then if we draw a line from the center, so the tangent point to that line, then we will have the radius, right? So let's call the radius, no, sorry, since the length of BC is 12, so this is 12, right? But then if we connect this, then and this, right? Then, sorry, and from C to B, right? Then this, yeah, so then this whole thing becomes an equilateral triangle, right? And so that angle would become 60 degrees, right? And so since that's 60 degrees, that means this arc is 1/6 of the circumference of the big circle, like that, right? And so, yeah, so if this is the radius of the big circle, and so let's say that's, yeah, so let's say the whole thing is like r, right? Then 2 pi r equals 6 times 12, so this is 6 times 6 times 2, so this is 72. So r equals 36 over pi, right? So r equals 36 over pi. This is 36 over pi, right? And since it's a number over pi, then this number would also be a number over pi, right? And so let's say that this radius, that's a over pi, right? If that is a over pi, then this much would be 36 minus a over pi, correct? Because the whole thing is 36 over pi, and this much is a over pi, so this much is 36 minus a over pi, right? And since this thing is 36 over pi, that means AB is also 36 over pi, but this is the midpoint, so that means at this point, yeah, so that length will be 18 over pi, right? So we have a right triangle with lengths a over pi, 36 minus a over pi, and 18 over pi, right? And so the ratio is the same, so we can just take out the over pi's, right? And then now we can use the Pythagorean theorem. So if we do that, then this will give us that 36 minus a squared, so which is a squared minus 72a plus 36 squared equals a squared plus 18 squared. So these two will go away. So 72a, this equals 36 squared minus 18 squared. This is 18 times 54, right? So a equals 18 times 54 over 72. So this is 54 over 4. This is 27 over 2, right? So this a came from here, right? And our first length was a over pi, right? And so the circumference of the circle, this is 2 pi r, so 2 pi times a over pi, so this is 2a, so this is 2 times 27 over 2, this is 27. So the answer is 27, it's D. Last problem, number 25. 8 congruent equilateral triangles, each of a different color. They are used to construct a regular octahedron. How many distinguishable ways are there to construct the octahedron? And two colored octahedrons are distinguishable if neither can be rotated to look just like the other. Okay, since one rotation making it the same, that would just make it constant, right? So for this one, we need to make one face constant, right? So let's make this face constant. So let's say that this face is just going to be painted with one color, right? So this is the constant face. No, let's not put the stripes in there. So this is the constant part. Constant. And if we have that part constant, then we will have 7 factorial ways of deciding the colors of the others, right? So this is because of the one face is constant, right? But then even if we have this face constant, we can also see that this triangle, and this triangle, they are like symmetrical, right? So we could have constant patterns of 3 overlapping, right? So if like this is color A, B, C, then that will be equal to the color being A, B, C, and also equal to the color being A, B, C, right? So we have 3 overlaps, so we have to divide this by 3. So we have to divide 7 factorial by 3. This is because of the rotations. Rotate, this gives 3 overlap, right? And so if we calculate this equals 7 times 6 times 5 times 4 times 3 times 2 divided by 3, so that cancels. This is 7 times 6 times 4, 5 times 4 times 2. This is 10 times 7 times 12, 24. So this is 1680, right? So this is 1680. The answer is E. So that was it for the AMC 12 from the year 2000, and thank you for watching.